Okay, Calder, here's some examples on the other type of factoring that we looked at. There was an example, there was problems that included perfect squares and difference of squares. Okay, so I'm going to go through a couple of those, and hopefully just seeing that process will help you a little bit better. Okay, so first I want to just start with this trinomial here. That's a perfect square, and we can do it the same way we did the other one. So I'm going to start that way and then show you why we do it a different way. Okay, so we can multiply 9 times 4 and we get 36. Ooh, that's an ugly 6 there. Let's erase that. And stop working. All right, we'll fix that. 36. All right, and then our middle 12 goes down at the bottom. And we want factors of 36 to add up to 12. So if we need to make a T-chart, we can use that to help us get those numbers. If you already know it, don't worry about the T-chart, just write them down. Okay, so 36, we do 1 times 36. 36 divided by 2 is 18. 3 times 12 is 36. 4 times 9 is 36. And 6 times 6 is 36. Our doubles there tell us to stop. Okay, so we want factors that are going to add up to 12. And if we look across in our table here, that 6 plus 6 adds to 12. Okay, so now let's rewrite our trinomial. We'll bring down our 9x squared. And then we have our sides from the x plus 6x. And then another 6 on the other side. And then bring down your constant at plus 4. And then we'll group them, 2 in each parentheses, and find the GCF. 9 and 6 have a common factor of 3. They can both be divided by 3, right? And they both have an x squared and an x, so x needs to be part of that GCF. And then we're going to divide each term. 9 divided by 3 is 3. X squared divided by x, I'll leave an x. And then 6 divided by 3 is 2. X's will cancel. 6 and 4 have a common factor of 2. They can both be divided by 2. And both those signs are positive, so we make that a positive. 4 doesn't have an x, so no x here. And then divide. 6 divided by 2 is 3x. 4 divided by 2 is 2. We have 3x plus 2 as our common factor. And then our GCF on the outside is 3x plus 2. Okay. Now, if you're getting this down and you just want to ignore these perfect squares patterns, because this is the same, right? Both our factors are the same, and we could rewrite this as 3x plus 2 squared. Okay, now, if you have that process down and you don't want to mess with it, you can do all of them like that. Okay, but there is a shortcut if you pay attention to the numbers. Okay, so notice here 9 is a perfect square. It's 3 times 3, right? And that's what we got, 3x. And this 4 is also a perfect square. It's 2 squared, and that's what we got in our factor, right? So, and then this middle term, 12, is 2 times 9 was 3 squared. So I use 3. And then 4 was 2 squared, so we're going to use the 2. So 2 times 3 is 6, times 2 is 12. And it matches this middle number. Okay, so if the first number is a square, the last number is a square, and this middle number is 2 times the square root of each of these terms, then this is a perfect square, and you can skip all of these steps and skip all the way down here. So if you know it's a perfect square and it matches that pattern, you can just automatically go to this form where you know it's a factor squared, right? Take the square root of that 9 is 3x, and then the square root of 4 is 2. Our middle sign is the sign that goes in our answer. Okay. So if you don't like the shortcut and it's confusing you, you can use this method just like the other ones, or you can take a shortcut when you see a perfect square. Okay. The other kind of special factoring that we can do is in when they have two terms. Both of these examples are two terms, right? So all of these other ones had three terms. They were trinomials. We can factor special binomials, they have two terms, if they are perfect, if they are both squares. 9 is a square and 16 is a square. And, excuse me, and it's a difference. It means it's subtracting, right? So if this is a difference of squares, then we can factor them. So if 9 is a square, we're going to take the square root, which is 3x. First term always has an x. And we can take that second term and take the square root. 4 times 4 is 16, right? We're going to have 1 plus, and then we're going to rewrite it again, but we're going to make it a minus. Okay. And then this one over here, 4 is a square. It's 2 times 2. And 9 is a square. So we'll take the square root, which is a 3. And it is a minus. So make 1 plus and make another one just like it, but we're going to make it a minus. Okay. So these are just shortcuts, special things that we can look for to help us factor some polynomials. Okay, let me know if these help you out. Let me know if you need more or if there's something else that I can do for you. All right, Calder, have a good day.